Welcome to another lesson with Transparent Physics. This is a companion lesson to the previous one on unit conversion. This time we'll show you some more advanced techniques for unit conversion. Between the last video and this video, it should be able to take you through pretty much anything you're going to see in your introductory physics adventures. And when I'm talking about advanced unit conversion, this is not an official designation, this is just my opinion. Stacked units, say miles per hour to meters per second. Squared, cubed units, etc. You can keep going from there, although you don't see it much more often besides squares and cubes, at least at the introductory level. So square feet to square meters, for example. And then we'll just do a problem just to show off putting all that stuff together and seeing some kind of neat, maybe slightly out of the box thinking on how to use unit conversion. It has its value, let's put it that way. Okay, so let's start with the idea of stacked units. Now, stacked units are going to work out just the same as the other kind of conversions that we talked about before. You're just going to basically need to do twice as much. You're going to need to convert the units on the top of the fraction, and you're going to need to convert the units at the bottom of the fraction. But the process is the same, and you can just sort of string it all along together. So let's take a look at what I mean by that. So example one, the North American and Eurasian tectonic plates are moving away from each other and widening the Atlantic Ocean at around 2.5 centimeters per year. How many feet is that per century? So we can use a unit conversion. So we're going to convert 2.5 centimeters per year to feet per century. So, as noted in the last video, 1 inch is 2.54 centimeters. I think everything else will be able to work out just on the spot, as they say. So let's take a look here. So we're going to start with what we're interested in, and we're going to say 2.5 centimeters per year. So that's basically a speed, a distance over a time. And we are interested in converting that to get to feet per century, and I'm going to argue that we can do this we could do it in 2 steps if we wanted to, but it might be more natural to do it in 3. Now, you are not obligated to know in advance of doing your problem how many steps it's actually going to take you. I just like to do it this way for the example, because then we can write where our goal is going to be, and our goal is going to be feet per century, and I don't know what a unit for century is, so I'm just going to write it out. Okay, so why don't we just start with the top like we normally would. We want to convert centimeters to feet, and centimeters to feet, I did write that there's 1 inch is 2.54 centimeters, so I'm just going to start with that guy right there. Now, inches is not what we want for our answer, but it's going to get us 1 step closer to the goal. So 2.54 centimeters for 1 inch. So the idea is that we've got centimeters divided by centimeters. Centimeters cancels out. And we have an inch, and we want to get to feet. For our non-American viewers, there are 12, the wonderful, what is it called? The imperial system of measurement. So 12 inches per foot. And so we're going to go 12 inches in 1 foot. And if we do our little sort of analysis here, centimeters cancels with centimeters, inches cancels with inches, and we're going to be left with feet. So we're done on the top, exactly like a normal problem would be. Now we want to get to the bottom. We want to convert years to centuries. The only difference here is now that the fraction has the unit we want to cancel out on the bottom. So if it's on the bottom, then we need to put it on the top to cancel it out. And we want to end up with centuries on the bottom. And there are 100 years in a century. Okay. And then just following that up, again, we have 1 year cancels with 1 year and leaves us with centuries. So our units cancel out. There's nothing different about this process. You just have to be careful. Common mistake is kids will forget that the year is on the bottom, and they'll just keep writing it as if they're canceling on the top. But the calculation should be moderately straightforward. I'll give you a view of what's going on in the calculator. Remember, if it's on the bottom, you divide. If it's on the top, you multiply. So 2.5 divided by 2.54 divided by 12 times 100. You can do it all at once. That's why I said in the last video, don't break this up into 2 steps. Just do it all at once. You just get it done. Okay, so that ends up giving us an answer of 8.2 feet per century. So there you go. The Atlantic Ocean is getting wider by 8.2 feet every century because of continental drift. Now you know. Okay. All right, so that's stacked units. Next up, squares, cubes, etc. Now, squares and cubes, you can look these things up on the internet, and you can find these values. You can find any conversion between any conversion that you want to. However, on an exam, or if you don't have Wi-Fi where you're working stuff out, you can work these things out. It takes another step or two, but I personally find it's more intuitive to do it this way than just to look up and write something down that Google tells you. Nothing wrong with Google, just saying, you don't always have to use it. Good chance for a quick tea break there, and there we go. Okay, so you can look it up. I'm not saying that you couldn't do it, but it's just going back to the basic principles of when we're talking about squares and cubes and things like that. It's just repeated multiplication. So a squared value is itself times itself. A cubed value is itself times itself times itself. So when we write centimeters squared, all we're really saying is centimeters times centimeters. If we write centimeters cubed, we just mean centimeters times centimeters times centimeters. So I think of it when I'm converting units with squares or cubes. It's just that if I have a squared centimeter value, I just need to make sure it cancels out twice. So the fraction shows up twice. If I have a cubed centimeters, I need to cancel it out 3 times. So it just tells me how many additional times I need to repeat that initial fraction that tells me, say, centimeters to meters. Let me show you what I mean by that. If I can get my paper. And it is a simpler task, I think. It's more intuitive, but people do complain that it makes the problem a little bit longer in terms of writing it out, and it's true, it does. I would rather have a problem that's a little bit longer that I get right than a shorter problem that either I screw up or I get right, but I don't understand how I did it. Let's take a look. If you are into fireplaces and stuff, you might know what a cord of wood is. I don't know where the term cord comes from, but it is a stack of wood that is 4 feet by 4 feet by 8 feet. And again, this is American measurements here. And so if you take 4 times 4 times 8, that's 128 cubic feet. And that's how you buy wood. Or you can buy like a quarter cord or half a cord and stuff like that. So let's say we are interested in the metric system, and we are interested in how many cubic meters a cord of wood is instead of cubic feet. So how do we do that? Well, again, I'm going to give you the free piece of information here is that there are 3.28 feet in a meter, a little over a yard. So how do we do this? So I guess we'll just do 1 cord. I said 1 cord, so we'll do 1 cord. All right, a little bit boring, but all right, so we have 1. I do not know what the abbreviation for a cord is, so I'm just going to write cord. So we have 1 cord, and we are interested in converting it into cubic meters. So I tell you what, let me do it this way. I'm going to start. I know that a cord of wood is 128 cubic feet. So I could have started off by writing 128 cubic feet, but I didn't. So we'll just take care of that step right now. So a cord, so 1 cord is 128 cubic feet. And again, a little redundant. I really could have just started by saying this as the value, but it is what it is. I'll get the problem in there too. Okay, the next step is I want to convert from cubic feet to cubic meters. And I know the conversion between feet and meters. So remembering that a cubic foot is really just a foot times a foot times a foot. That's really all it is. A cubic foot is just a foot 3 times. So when I'm thinking about how to set up my conversion, I could think of it like this. 1, 2, 3. And I know that there are 3.28 feet in 1 cord. So in the process of doing that, I'm not done with the problem, but what did I do? I canceled out one of my feet. And I made a mistake there because it's not obviously 3.28 feet per cord. It's 3.28 feet per meter. The math is the same. My nomenclature was off. So it's 1 meter is 3.28 feet. I apologize for that. I won't make that mistake again in this video. All right. So I got rid of one of my feet, and I got a meter. I want to get cubic meters, so I want to get 3 of these, so I have to do this 3 times. That's all it is. Again, some people like this technique. Some people think it's You make your pick, but make your pick at least having all the information. So when I do this, feet cancel with feet cancel with feet, and I've got a 1 meter, a 2 meters, a 3 meters. So we have 3 meters. A meter times a meter times a meter is a cubic meter. So when we're all said and done, zoom out a little bit again. Wrong way. All right. So when it's all said and done, I'm going to have now cubic meters. That's how it works. So I've taken, I don't need to look up on the internet to know what a cubic foot is compared to a cubic meter, because I know what the relationship is between a meter and a foot. And if I want to get rid of a cubic foot, I just have to do the conversion 3 times. That's all. That is all. So we're going to go 1 cord. Well, I guess we'll start there. All right, 1 cord times 128 divided by 3.28 divided by 3.28. And again, there's mathematically faster ways you could do this. I know. I'll just show you the solution the way we worked it out. And that gets you around 3.63 cubic meters. Okay, well, so now our friends from around the world know exactly how many, what the volume of a cord of wood is in the SI system. So there you go. So both stacked and squared/cubed units don't require anything new in terms of your technique. They just require you to apply it smartly. So just to show you how this might work out, I'm going to give us a little bit more of an advanced question just for fun. So if you've got a solid gold can of soda, depending on where you live in the United States, we also might call it pop. So if someone was to, if some internet celebrity was to say, hey, here's a solid gold can of soda and throw it at you, what would that be worth? That said, of course, the value of gold changes moment by moment, so I'll just do a little snapshot in time. So we'll imagine a solid gold can of soda, and what would the monetary value of that be at this given moment in our history? Well, the can itself is 12 fluid ounces. So this is a little bit of an open-ended question. You're going to need to know a couple different things in order to make this happen, and I'm going to choose a couple values that are just not probably what you would normally do, just to show you how this technique applies using both stacked and squared. So I'm going to make it a little artificially difficult just to show you all the processes in action. So if you sat around and thought about it a little bit, we probably would need to know what a fluid ounce is, and 1 fluid ounce is 29.57 cubic centimeters. The classic US system here, or well, imperial. The Brits are to blame for this too. Okay, next up, we're going to go, gold itself has a density, and let's say the density of gold, well, not let's say, the density of gold. Now again, this is not the value you would normally use. This is a scale too big, but we're going to use it just so we can show you how these conversions work out. And this is the density of gold. So if you had a cubic meter of gold, first of all, congratulations if you have a cubic meter of gold, but it would be 19,320 kilograms in mass. But you wouldn't have to worry about how heavy it is because you'd have enough money to pay a bunch of people to lift it up for you. And I think the last piece of information we're going to need that isn't, say, just a unit metric kind of thing, is that the value of gold, I looked it up a couple minutes ago. As of that moment in time, it was $62.76 per gram. Okay, so we're going to do some conversions. And again, please, I mean, if you want to write in the comment thread that you didn't do this as efficiently as you could, transparent physics, yes, I know we're not going to do it as efficiently as you could. The purpose here is just to show you some of these techniques strung together, how they would look in a more complicated problem. Okay, so we're going to go, instead of starting with 1 can, we're going to just start with 12 fluid ounces. So we're going to go 12 fluid ounces, and we're going to convert that to dollars. All right, fluid ounces to dollars. Let's see, let's make it happen. Okay. So, step number 1, I'm just going to write 12 fluid ounces. I'll give it a little extra precision there. Fluid ounces. So 12 fluid ounces. Now, I'm not going to predict exactly how many fractions we're going to need for this because, again, I'm making it a little long just for demonstration's sake. So we're going to convert fluid ounces to cubic centimeters. And again, that information is just set up already for us in terms of our values. So we have fluid ounces on bottom, and we have cubic centimeters on top. Fluid ounces cancel with fluid ounces, leaves us with cubic centimeters. That's 29.57 cubic centimeters per fluid ounce. So the next thing we're going to look is we have a value that's going to give us the mass if we know the volume. So this is the volume in cubic centimeters. This is the volume in cubic meters. So we're going to need a conversion between these two if I want to take this information and convert it to mass, because mass is ultimately the designation by which the gold is valued. So I have cubic centimeter here. I want to get rid of a cubic centimeter, so I'm going to need unos, dos, tres. I'm going to need 3 centimeter conversions. Centimeter, 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 meter, meter, meter. And I didn't write this down specifically, but there are 100 centimeters in a meter. So what I've done here is I've taken centimeters cubed. Centimeters cubed is really just centimeter times centimeter times centimeter. And I've canceled it out 3 times, thus giving me cubic meters. So right now, after this step, I have cubic meters. And if I have cubic meters, now I can figure out how many kilograms I have, because I can put cubic meters on the bottom and kilograms on the top. And again, if I was doing this for real, I would probably have just done grams per cubic centimeter. But, you know, we're just having some fun on the internet. Okay, so after this step, fluid ounces have canceled with fluid ounces. Cubic centimeters have canceled out, leaving us with cubic meters. And then cubic meters have canceled out, leaving us with kilograms. So if I was to stop right here, that would tell me how many kilograms, what the mass in kilograms would be of a 12 fluid ounce bottle of solid gold. We're close, but we're not there yet. We're going to convert grams to kilograms at this point. And again, that's not a conversion I wrote out to start. I'm going to, just to make sure I don't crush on the bottom, I'm just going to continue it down the next line here. I could maybe squeeze it in, but that's not good etiquette. So I'm going to go kilograms. Kilograms is on the top. So I want kilograms on the bottom of the next fraction, and I'm going to want to convert it over to grams. And again, if you don't know, now you do. There's 1,000 grams per kilogram. So in this case, kilograms cancel with kilograms, leaves us with grams. And we're on our final step now. We have grams on the bottom of this, dollars on the top of this. Grams cancel with grams. And we're left with dollars. So when we do our calculation, we have dollars as our final value. Okay. Just for fun, go ahead, take your guess right now. Would you give up a year of your salary for I don't know, well, you may not have a salary depending on how old you are. Let's say you make, I haven't figured this out yet, so I don't know the exact answer. If you make $100,000 a year at your job, would you take a solid gold can of soda as opposed to working for a year at your job? Let's find out. Well, maybe nobody wants to work a year at their job. How about if they just offered you, maybe if they offered you 100, okay, here's the deal instead. They're going to offer you $100,000 or a solid gold can of soda. So you still have to go to your job. All right, so we got, let's take a look here. 12 fluid ounces times 29.57. Excuse me. Good time for tea. And again, we can string this all together. Divided by 100. Divided by 100. Divided by 100. Times 19,320. Drop a line. Times 1,000. Times 62.76. Okay, see if you made your decision. $100,000 or a solid gold can of soda in 3, 2, 1. Ooh, look at that. So at current rate, wow, at current rates, we'll just round. So at going rates, a solid gold can of soda would net you just a little under $500,000. So you would be better off taking the solid gold can of soda as opposed to $100,000 by a long shot. Okay, so there we go. This is just some other applications of unit conversion. Now, again, you may not have to convert fluid ounces to gold value anytime soon in your physics class, but I guarantee you, as they say, dollars to donuts, that you will have stacked units that you have to do. Meters per second to miles per hour shows up all the time. And it is not uncommon for there to be squared and cubed units as well showing up. So between these two advanced techniques and the stuff that we talked about in the previous video, you should be in pretty good shape. And I was going to make some joke about $430,000, but I can't come up with anything right now. So we'll just leave it at that then, I guess. Hey, I appreciate you stopping in for another lesson here, and I hope we've made things clearer for you and perhaps slightly richer with this episode of Transparent Physics.